Okay. Last meeting, we started a new topic is dealing with indeterminate structure. And I explained what is the meaning of indeterminate structure. Indeterminate structure means number of unknowns is greater than number of equations. If this is the case, we cannot solve for unknowns. We cannot solve for reactions. Mathematically, we cannot. If you cannot solve for reactions, I cannot solve for axial force, shear force, and the bending moment diagram, the internal force. And I explained what is the advantages and the disadvantages of indeterminate structure. Advantage and disadvantage of indeterminate structure. Do you like to make your structure determinate? Do you like to make your structure indeterminate? Based on the situation. If you have a structure and we have a big concern about temperature, or we have issue with the soil, so we need to avoid the effect of settlement. If you have a structure with big concerns about settlement and the temperature, make sure your structure is determinate, like bridges. If we don't have issue with temperature or settlement, make sure your structure will be indeterminate, will be better. If the structure is indeterminate, you can get smaller stress, smaller bending moment, greater stiffness, stronger structure, and also if we have issue with one of the columns or piers or supports, we will not expect catastrophic failure. Okay. And the last meeting also, I started with a new method. This method will help you to solve indeterminate structure. Actually, we have three methods. Consistent deformation method, slope deflection method, moment distribution method. Because we don't have enough time, the first two methods, we will not cover them this semester. However, if you would like to get more information about them, I have recorded videos about these two methods. So I will focus on the third method, moment distribution method. So what is the difference between the three methods? No difference. All of them will solve the indeterminate structure. The only difference, how, steps, process. This is the only difference, but all of them will give you the final answer, which is solving of indeterminate structure. Okay, let's continue. Moment distribution method. From the meaning of this method, we have a moment. We need to make distribution for this moment. We need to make distribution. I started with first term, stiffness factor. This stiffness factor is indicator, is an indicator for the strength, or this member is strong or weak. This factor K equal 4EI divide L. So for example, if you have a beam, looks like this. This beam has length in the denominator 4EI divide L. I would like to explain and to confirm this information. L is the length of the member. If you have longer beam, you will have weaker beam. That makes sense? That makes sense. If you have longer L is at the denominator, so this value of the K stiffness factor will be smaller for longer L. Smaller K means weaker beam. If you have shorter beam, that means smaller L, that means bigger value for K, that means stronger B. That makes sense. So the denominator, I would like to make the denominator smaller as much as I can. The numerator, I would like to keep these values bigger and bigger and bigger. Because if the numerator is bigger, the value of K will be bigger, the beam or the member will be stronger. That makes sense? E depends on the material of the member. Steel is the strongest one. Concrete is good. Wood is weaker, and so on. I is the moment of inertia. I for this cross section, PH cube divide 12, based on the dimension, this dimension and this dimension. Anyway, distribution factor. Do you remember the example I told you last meeting? If we have a chicken and I will distribute this chicken based on your score in the exam. So student, the score divide summation of all students. The score, I can give you your factor of distribution. Does that make sense? So we will divide K for the member, divide summation K for all members at a certain point. I can give you the distribution factor. Guys, last meeting also I told you, if we assume each member in the beam as fixed supports, based on the case of the loading, I can figure out the moment at this fixed. This fixed moment will be called fixed end moments. We assume each member as fixed. So for example, the first one, we have concentrated load at distance A from left, distance B from right. The fixed end moment here will be PA square B divided L square. L is the total length. The other moment will be PB square A divide L square. And make sure the moment clockwise direction is positive, the moment counterclockwise direction is negative. That makes sense? If you have two concentrated load at 1/3 and 1/3, guys, be careful. Your concentrated loads are equal, P and P. At distance, L divide 3, L divide 3, and L divide 3. 3 equal spacing. The moment will be 2PL divide 9 positive and 2PL divide 9 positive. If you have uniform distributed load, WL squared divide 12. WL squared divide 12. Positive and negative. Positive and negative. If you have right angle triangle, at the lowest value of the distributed load, W squared divide 30. At the biggest value of W, WL squared divide 20. Any question so far? If you have any question, let me know. What is the concept of this method? Okay, let me explain it quickly. Guys, for this beam, we have fixed at A, roller at B, fixed at C. The idea for this method is, I'm gonna assume the first member AB as fixed. A, B. and the other member BC as fixed. Right now, I'm talking about the concept of this method. So we have BC. Okay. The first member under the effect of one concentrated load, 25. And this distance A equal 3, this distance B equal 3, the distance L equal 6 meters. Can you tell me what is the fixed end moment here? What is the fixed end moment here? Yes, I can. If you go back here, I think we are in this method. So in this case, concentrated load over fixed members. So your moment will be 25 times A square times B divide L, I think, divide L square. Yes. Divide L square. This moment will be 18.75 positive. And this moment will be 18.75 negative. You are lucky. Both of them are equal because this distance equal to this one. It's a special case. Okay, looks good. Looks good. What about the other member? The other member under the effect of uniform distributed load with a value 15 kilonewton per meter and the length equal 4 meters. I believe your moment here and your moment here will be this case. WL squared divide 12, WL squared divide 12. Okay. W is 15, L square 16 divide 12. Your value will be 20. Your value will be 20. And remember, this 20 is positive, this 20 is negative. What is the problem? The problem is at this point B, we must have equal moment. Because it's the same point. At this point, from this side and from this side, we must have equal moment because it's 1 point. It doesn't make any sense because we have right now positive 18.75 related to this side and the negative 20 related to this side. Doesn't make any sense. Both of them must equal 20 or 18.75 or something in between. So what do you think? What is the difference between this one and this one? We have, I believe, 1.25 moment between the two values, 20 and 18.75. That makes sense? So what do you think? Probably, I will decrease 20 to be 19, negative 19. And I will increase 18.75 to be positive 19. So both of them are equal. I don't care about the sign, positive or negative. It's not my point. I'm talking about the value itself. The value. I need to make the two values are equal. So we have option. I will decrease 20 by 1. And I will increase 18.75 by quarter. And both of them will equal. This is a solution. We have another solution. What do you think if I reduce the 20 by half? So it will be 19.5. And I will increase 18.75 by 0.75. So it will be 19.5. This one negative, this one positive. So what you did right now? I decreased this one by 0.5. I increased this one by 0.75. In the previous solution, I decreased this one by 1. I increased this one by quarter. My target, I need to make this value 20 equal this value 18.75. So I would like to reduce this value a little bit and increase this one a little bit to be equal. So if you think about this, we have infinity number of solutions. How much I can reduce this value, how much I can increase this value based on the distribution factor. And this distribution factor based on the stiffness factor of the member. Guys, did you see anything here for this solution, or even this solution, or even another solution? Believe me, the value you will use here and the value you are gonna to use here, both of them, if you sum both of them, will equal the difference, 1.25. Here, 0.75. If you add both of them, you can get 1.25, which is the original difference between the two values. So the idea is, I will assume each member as fixed, and I will get this moment, and I will get this moment. My target right now, I would like to make sure both of them are equal. I think this one should be negative. Anyway, I would like to make sure both of them are equal. How can I make the two values equal? I will distribute some moment. And this distribution based on the distribution factor. And the distribution factor will depend on the strength or the stiffness of the member. I have another question before starting to solve a problem, because solving a problem is a game, piece of cake. It's very easy, don't worry. But I'm trying to explain the concept. Guys, if you have a roller, can you bring a roller? Flexible one. Can you catch the two rollers with your two hands, one here and another hand here? Your hand and the other hand. If you try with this side to rotate this end, can you try to rotate this end? If you try to rotate this end, I believe you will have this deformation. So any change on this side will affect the other side. Even if you didn't do anything here, you are keeping your hand catching this end. You didn't do anything here. You rotate only the other hand. Anything on the other hand will affect on the other side. If you did a value here 1, the effect on the other side will be half value. If you did effect here 2, the other side will be 1. If you did 3, the other side will be 1.5. So the effect on the other side will be half value, which you call carry over moment. What you mean by carry over moment? I mean, you will increase this value. Any change will affect on the other side. You will decrease this value a little bit. Any change will affect on the other side of the same member. One more thing I would like to highlight before starting the first example, and I need answer from you. Guys, if you are living with your roommate. I think roommate is written like this. If you are living with your roommate, 1 or 2 or 3 in one apartment, and you have a chicken, I think that makes sense if I'm saying, hey guys, we have a chicken and we need to distribute this chicken among you and your roommates. Does that make sense? So we have many peoples, more than one, and we need to distribute this chicken. That makes sense. It's a real question. It's a real question because we have many students, many people, many persons, and we need to distribute something among them. So this question is a real question. But it doesn't make sense to me if I'm saying, hey guys, you are living alone in your apartment. You are living alone. You are right now alone in your apartment and you have a chicken. Can I say, hey, Zach or Benjamin, hey, can you distribute this chicken? You will say, are you kidding me? I'm living alone and this chicken is for me. So how can I distribute it? I will eat the whole chicken alone. That makes sense? So if you would like to make distribution, we need at least 2 or more. But if you are 1, we don't need distribution because doesn't make sense. If you are 1, you don't need to distribute anything. Does that make sense? Guys, does that make sense? So if you would like to make distribution, we need at least 2. But if you are 1, we don't need any distribution. Does that make sense? Okay. Let's start our first example. We have a beam fixed at A, fixed at C, roller at B. And we need to find or determine the bending moment at A, B, and C using moment distribution method. Okay, first step, what is the stiffness factor for each member? K, AB, K, BC. Okay, go back here. Stiffness factor equal 4EI divide L. Do you have a value about EI? No. Okay, keep it. 4EI divide L. What is the length of member AB? 8 meter? Okay, 8. So if you would like to simplify, it will be EI divide 2. That makes sense? What is the stiffness factor for the member BC? Okay, 4EI divide L. What is the length of this member BC? 8. Wow, good. If you would like to simplify it, EI divide 2. Any question about the first step? Looks good. Second step. Distribution factor. If you would like to do distribution factor for any member equal K for this member divide summation K. But I have question here. Do you like distribution factor at A or at B or at C? Any answer? Do you need distribution factor at A, at point A? Or do you need distribution factor at point B? Or do you need distribution factor at point C? Or all of them? What do you think? I need answer. A or B or C or all of them. Any answer? Okay. The correct answer, like Zach said, point B. Guys, if you are living alone in your apartment, doesn't make sense to make distribution because you are alone. But if you are 2 or 3 or 4 students or persons, we can make distribution. Okay? Anybody can tell me at point A, how many members do you have at A? How many members connected at point A or joint A or support A? How many members? Only one. We don't need distribution. At point C, how many members do you have connected at this point? We have only one member. We don't need distribution. But at point B, how many members do you have? I think we have BA and we have BC, so we have at least 2 members. We can do distribution. That makes sense? That makes sense? Looks good? Okay. So I'm trying to simplify the concept. We will not distribute chicken, but we will distribute moment. But the concept is the same. If you have only one member, we don't need distribution. At this joint, A, and the C also, we don't need to make distribution. But at B, we will do. Okay? So can you tell me what is the distribution factor for BA? What is the distribution factor for BC? This side BA and this side BC. Yeah, I can tell you, if you go back here, distribution factor equal K for this member divide summation K. Okay. What is the value of K for member BA? BA is the same like AB. EI divide 2. What is the summation of all members at B? We have this member and this member. So we have this value and this value. So EI divide 2 plus EI divide 2. Your factor will be 0.5. If you simplify, this one will cancel this one and this one. If you simplify these numbers, you will get 0.5, believe me. The same distribution factor for BC, the key value for BC is EI divide 2. Divide EI divide 2 plus EI divide 2 for the 2 members, summation. You will get 0.5. So at this side and this side, we have distribution factor, 0.5 and 0.5. Why you didn't get distribution here and you didn't get distribution here? Because it doesn't make sense. Because we have only one member. I cannot do any distribution. And at C, we have only one member. I cannot do any distribution. But for point B, we have 2 members. So we will do distribution. So any question so far about step number 1 and step number 2? Third step, another piece of cake. Third step, fixed end moment. Guys, I'm gonna assume AB, member AB as fixed, and the member BC as fixed. Remember, we have two members, AB and BC. So I'm gonna assume the first one fixed with this concentrated load 40, and this distance 6 and 2. So I think P equal 40, A equal 6, B equal 2. I can figure out the value of moment here and the value of moment here based on the situation. So I think your values will be 40, this value will be 45 positive, and this value will be 40, 15 negative. The second member with concentrated load at equal distance. Okay, anyway, concentrated load 20. And this distance 4 and 4. So A equal 4, B equal 4. You are lucky. So your moment here and here will be 20. I think your value will be 20 and 20. So this value is positive. This one will be negative. So I can say M fixed AB equal negative 15, M fixed BA equal positive 45, M fixed BC equal negative 20, M fixed CB equal positive 20. Any question about the third step? We almost done, by the way. We almost done. So guys, first step, I need to figure out what is the stiffness factor for each member, any member in your beam. Then I will do distribution. I'm asking you which point I'm gonna do distribution, A or B or C. You told me B. That makes sense. The third step, fixed end moment. I'm gonna assume each member as fixed. Each member as fixed. Based on the case of the load, I can figure out the fixed end moment value. We have issue right now. You know why? At point B, this point B is 1 point. 1 point. We must have equal moment. However, we have here 20 and we have here 45. Doesn't make any sense. We need to increase 20 up a little bit and decrease 45 down a little bit to make sure the two moments are equal in values. Equal in values and opposite in sign. One will be positive and one will be negative, but equal in value. The issue right now, we have an equal values, 20 and 45. So how can I do this? We need to increase 20 up and we need to decrease 45 down to make sure both of them are equal. So we have many options. We can increase 20 by 10 and decrease 45 by 15 to make sure the two values are 30. Another one will say, hey, I will increase 20 by 5 and decrease 45 by 20, and both of them will be 25. Okay, how can I handle this? The last step. It's a game. I will draw lines at each joint down, and I will write here distribution factor. Do you have distribution factor at this side? No, 0. Do you have distribution factor at these two sides? At point B, yes, 0.5 and 0.5. Do you have distribution factor here? No, 0. This is what I said here. This is what I said here. At point A or joint A, we don't have factor, distribution factor. At C, we don't have distribution factor. But at B, we have distribution factor. This side, BA. This side, BC. 0.5, 0.5. Okay. What is the fixed end moment? What is the fixed end moment? I'm sorry guys for this noise, just a second. So what is the fixed end moment? Okay. Fixed end moment AB negative 15. AB negative 15. BC, I'm sorry, BA positive 45. BC negative 20. CB, this side, positive 20. Any question so far? So right now, in the fourth step, what I did, I draw vertical lines. I put my distribution factor. I put my fixed end moment distribution factor in step number 2, fixed end moment in step number 3. Any question so far? Any question? Looks good? Okay. I will add here distribution moment, then carry over moment, then distribution moment, then your final moment. And we are done. It's a very simple game. Let's do it. Guys, distribution moment. One more question. Do you have any distribution here? At this side, no. At this side, no. Do you know why? Because this side, at this joint, we have only one member. We don't have distribution factor and we will not have distribution moment. Because we have one person living in the apartment and he will eat the whole chicken. We cannot distribute anything because we have one member. So we don't have distribution. The same at point C or this side, CB. At this side, we don't have any, we have only one member. So we cannot make distribution. At B, we can do distribution. How can I get this value? And this value, it's a very simple. 45 positive plus negative 20. If you add this value and this value, you will get positive 15. I'm sorry. Positive 25. I'm sorry. If you add this value, negative 20, plus this value, positive 45, I'm gonna get positive 25. Can you change the sign? You got positive, make it negative. Can you multiply this value, negative 25, by this distribution factor, you can get negative 12.5. Can you multiply this value by the other distribution factor? You will get negative 12.5. Carry over moment, this value, negative 12.5, will affect on the other side of the member by half. You will get here negative 6.25. And your effect here is 0, will affect here by 0. This one will affect here by 0. This one will affect here by half value, negative 6.25. One more time. Distribution moment. At this side, we don't have distribution moment. At this side, we don't have distribution moment. Add this value plus this value, you will get 0. Change the sign to be 0. Multiply 0 by 0.5, you will get 0. Multiply 0 by 0.5, you will get 0. Once you get zeros, okay, go ahead and add all of these values together. We will have negative 21.25. These values together, we will have, just a second, 20 minus 6.25, 13.75. What is the value here? 45 minus 12.5, I will get 32.5. The other side, negative 20 plus negative 12.5, you will get negative 32.5. And I am good. I am done. I am done. The final moment at this side will be negative 21.25. The final moment at this side will be positive 32.5. At this side will be negative 32.5. At this side will be 13.75. How can I know I am good? I am correct. This value and this value are equal in values but opposite in sign. 32.5, 32.5. Guys, I told you we have big issue. The fixed end moment here was 20. The fixed end moment here was 45. The main target, we need to make sure both values are equal. I did 32.5, 32.5. Equal in values, but opposite in sign. One more example. I will do one more example to make sure everything is good. Before starting the second example, any question? Wait for the second example and you can ask me what you want. Guys, for the second example, we have 4 steps. The first step, what is the stiffness factor? Remember, K for member AB is the same like K for member BA. AB or BA, same meaning. 4 EI divide L. EI is not given. Okay, keep it. The length of this member, 36. Can you simplify? Yes, I can. EI divide 9, I believe. We have another member, BC. So K, BC will be the same like K, CB. Equal 4 EI divide L. 4 EI is not given, but it's a constant. So keep it. Divide L, 24. Simplify, EI divide 6. That makes sense? This is the first step, piece of cake. Second step, we need to calculate the distribution factor. My question is, do you like to make distribution factor at A or B or C? Your answer? We need to make distribution factor at what? No, not A. Because at A, we have only one member. At C, no, we don't have, we have only one member at C. But at B, we have two members. So I need distribution factor for BA, distribution factor for BC, both of them at point B. That makes sense? Okay, go ahead. Put your numbers. K for member BA equal EI divide 9. Divide summation of all the two members. So EI divide 9 plus EI divide 6. One more time. Sorry guys for this noise. So can you simplify? I think EI will cancel by EI and EI. So I can simplify the nominator is 1 divide 9. Divide 1 divide 9 plus 1 divide 6. 0.4. Distribution factor for BC, the K for BC is EI divide 6. Divide EI divide 9 plus EI divide 6. I think your value here will be 0.6. By the way, to make sure you are in the right track, make sure that the distribution factor for BA plus distribution factor for BC must equal 1. The whole chicken. Guys, if you are eating, if we have two students or two people eating a chicken, so the part for the first person plus the part of the second person equals the whole chicken. That makes sense? So the distribution factor for the first member plus the distribution factor of the second member must equal 1. The whole moment. That makes sense? Third step. Fixed end moment. Okay. I will assume member AB as fixed. I will assume member BC as fixed. What do you have on member AB? We have uniform distributed load 2 kb per foot. So we are right now in this case. WL squared divide 12. So your value here and your value here will be WL squared divide 12. W is 2 L square. I think the length of this member, how much? 36. Your value here will be 216 negative. I'm sorry, this one is positive, 216 negative. The other one, we have uniform distributed load here. How much? 3 kb per foot, and the length is 24. Your moment here and your moment here, W squared divide 12, W3, L square divide 12, your value will be 144 positive, negative 144. So if you would like, M fixed AB negative 216, M fixed BA positive 216, M fixed BC negative 144, M fixed CB positive 144. Guys, we have a big issue here. The value here is 144 at B, related to this B. And the value here at B, 216, related to this beam. We have a big issue here right now. We need to increase 144 up, and we need to decrease 216 down to make sure the two values are equal. So we have the fourth step. I will draw vertical lines at each joint, A, B, and C. And first, I will put my values, distribution factor, and the fixed end moment. Distribution factor. Do you have distribution factor at this side? No. Do you have distribution factor at this side? No. Do you have distribution factor at B? Yes. On this side, BA, we have 0.4. BC, we have 0.5. What is the value of fixed end moment? AB, negative 216. BC, positive 216. BC, negative 144. CB, positive 144. We need to do distribution moment, then carryover moment, then distribution moment, then I will add to get the final. Does that make sense? It's very easy. This problem is very easy in your exam. Okay. Keep in your mind this concept. At this side, do you have any distribution moment? No. Do you have any distribution factor? No. So 0 and 0 for distribution moment. At point B, we will have. How can I do this distribution? Guys, you need to add positive 216 plus negative 144. The value of moment here and the value of moment here, and you keep your sign with the values. So we have positive 72. You are lucky. The value is positive. Okay. Change the sign. So it will be negative 72. Go ahead and multiply this value by this distribution factor. So negative 72 times 0.4, negative 28.8. This value one more time, 72 negative 72 times 0.6. I think this one is 0.6, not 0.5. I'm sorry. Negative 0.6 times 0.6 will be negative 43.2. One more time. How can I do the distribution moment? It's easy. Add this number to this number. The value changes the sign. If you have positive, make it negative. If you have negative, make it positive. Once you change the sign, go ahead and multiply this value by this factor to get this value. Multiply this value by this factor to get this value. Then I will do this cross. Very easy. Each number will affect on the other side by half value. 0, half 0 is 0. 0, half 0 is 0. Negative 28.8 will affect on the other side by negative 14.4, half value. Negative 43.2 will affect on the other side by negative 21.6. Distribution moment, one more time. Do you have distribution here? No. Do you have distribution moment here? No. Then go ahead and add this value by plus this value 0. We will have 0 and 0. Go ahead and add all of these values together. Negative 216 negative 14.4, you will get negative 230.4. Go ahead and add all of these values together. 216 positive, negative 28.8, 187.2. Add these values together. Negative 144, negative 43.2, negative 187.2. Wow, you are lucky. You are good. Your answer is good. Negative 21.6. This value will be 122.4. Do you know how can I know my answer is correct? This value and this value at point B must equal and different in sign. One will be positive and the other one will be negative. But the two values are equal.